Good evening and welcome to the Bruckner household. Lucky for everybody, there's nothing interesting going on, so instead, might as well show you lesson 1-5. Again, you're expected to take notes. Um, I will be checking these notes. I could be checking these notes, and there is another few questions for you to do at the end of this particular set of notes. So let's get right into it. Some of you guys have some of this written down already, so um, it might be new pictures, might be something else helpful. Check it out. So 1-5, we're talking about angle pairs. Again, all angles in twos. So the first set is adjacent angles. And as you see on the screen, adjacent angles are two angles with a common side and a common vertex. So the picture that is drawn below has three different angles, 1, 2, and 3. Angles 1 and 2 are adjacent angles. Angles 2 and angles 3 are adjacent angles. They are sharing sides. Angles 1 and 2 share this side, and they have that vertex. 2 and 3 share this side, and they have that vertex. 1 and 3, while they share a vertex, do not have a common side. As a result, they would not be adjacent angles. Moving on. Next is complementary angles. Complementary angles are any two angles that add up to 90 degrees. And so there's two different pictures here written. Uh, this picture on the left-hand side of a right angle in total is then broken by some ray, segment, or line. And those two angles that are sitting here, this angle, these acute angles, have to be complementary. They don't have to be sitting next to each other. These are complementary and adjacent. These two angles are not adjacent over here, but are definitely complementary. Supplementary angles. Two angles that add up to 180 degrees. So on a line that adds up to 180 degrees, you definitely have two angles that are supplementary. All straight angles are 180 degrees. Each of these, this acute, this obtuse angle, those are definitely going to be supplementary. True or false? Any two right angles are supplementary. Any two right angles. True. They're 90 degrees. 90 plus 90 equals 180. Good. Those are supplementary. Next we come to angle bisector. An angle bisector is any line, ray, or segment that cuts an angle into two congruent angles. So consider the picture that we have here, angle SDM. That is a relatively large obtuse angle. We've talked about having estimates there. I don't know, I may estimate that whole angle SDM, 135, 145 maybe, something like that. And ray DG, or in this case segment DG, is bisecting that angle. If something bisects an angle, it cuts it into two congruent angles, which means that I have the ability then to draw in the two congruence marks. Those two angles are then congruent, angle SDG and angle GDM, if DG is an angle bisector. And the next set of angles, one we have not talked about, are called vertical angles. Vertical angles are very important angles. We will discuss them for a long time. They will show up in a lot of different pictures. Vertical angles are two angles that lie on opposite sides of a vertex and are created by the intersection of two lines. So sometimes there are some very confusing pictures that have multiple lines and segments in them. You will know vertical angles are vertical if only two lines create those angles. And you can see that in the picture below. Here are two lines, and they are creating those four individual angles. Now there are more angles down there than just those four, but for starters we will just talk about angles 1, 2, 3, and 4. There are two pairs of vertical angles in that picture. What pairs are those? Angles 1 and 3. these two angles, 1 and 3, they lie on opposite sides of this vertex right here. And these two lines, these two segments in this case, create angles 1 and 3. That makes them vertical. Angles 2 and 4 are vertical angles. Angles 2 and 4 also have this vertex. They share a vertex. They're on opposite sides of that vertex, and it's still these two lines that create them. So I have two pairs here, 1 and 3 and 2 and 4. Now I'm not going to write the next thing down. You definitely should. All vertical angles are blank. All vertical angles are, well, let's take a peek at this picture. Let's see what they look like. Angle 1 and angle 3 are vertical angles. They are both obtuse angles. And if I look at them, kind of spin my head, maybe look at how much I think their measure might be, I think they look to be about the same. And as it turns out, they absolutely are. All vertical angles are congruent. So angles 1 and 3 are definitely congruent. Angles 2 and 4, these are acute angles. They look to be about the same, and they are. Those two angles are definitely congruent. All vertical angles are congruent. Make sure you write that down. Same picture, different definition. Now we're going to talk about linear pairs. Linear pairs are two adjacent supplementary angles. So they are linear, they're on a line, they are adjacent, they are right next to each other, and they're supplementary. So going back to my picture, I'll erase what we had up here already. I have many linear pairs here. Let's start by dealing with this line. Angles 1 and 2 are a linear pair. They lie on a line, they are adjacent, they're next to each other, and they're supplementary. We call those a linear pair. So not only angles 1 and 2 are a linear pair, but now angles 2 and 3, angles 3 and 4, and angles 1 and 4. Those are all linear pairs. Linear pairs are supplementary. If you find them, add up one angle to the other angle, and that will equal 180 degrees. So here's a question, algebraic in nature, that you're more than welcome to draw a picture down for. I am not going to, but this class is about drawing and about having a good idea of the vocabulary. We're going to discuss vertical angles and finding x. So two vertical angles have measures of 3x plus 7 and 2x minus 38. I'd like you to solve for x and find the measure of these angles. Okay? So I think back and say vertical angles. Vertical angles are congruent. If vertical angles are congruent in math, that means equals. So those two angles are equal to one another. 3x plus 7 equals 12x minus 38. Now I'm going to perform some algebra. Subtract 3x from both sides, add 38 to both sides. Get 9x is equal to 45. Divide by 9, x is equal to 5, and then I make sure I answer the question. I did solve for x, but I'd also like to find the measure. So to find the measure, you plug into either of the angles. They're congruent, so it doesn't matter. 3 times 5 plus 7 is 15 plus 7 is 22 degrees. Could have done the same thing for linear pairs, except linear pairs would have had a different result because clearly they would be supplementary. Your notes are what I could potentially check, plus page 41, numbers 8 through 16 all. Please take care of that. Have a great weekend, and I'll see you on Monday. Bye.